So the case of Chequamegon Bay. It's really an interesting area, a natural embayment that's largely enclosed, much like Green Bay on Lake Michigan. Has some tributaries contributing some significant nutrient loads to the bay. It's shallower, it's warmer. So I really enjoyed Bob Sterner's talk about the importance of and the opportunity to study Lake Superior in terms of climate change. And I might argue that Chequamegon Bay brings some extra value to that because of some of those characteristics. Elevated phosphorus levels have been measured within Chequamegon Bay since 2008, sometimes more, 10 times more than the state's standard. As Bob Sterner mentioned, there's been some significant algae blooms in that area, both in Chequamegon Bay and the Apostle Island National Lakeshore. And not only do we have increasing temperatures, but there are changes in land use practices, also with a proposed confined feeding operation in the Fish Creek watershed. So some possibilities of increased nutrient loads to the bay. To support the CSMI efforts in 2016, we brought a research vessel to Chequamegon Bay. We brought some of our equipment, including our V-fin tow body with a CTD package, an LOPC, laser optical plankton counter, our ABCP, and also our autonomous underwater glider to the area. We brought that outside of Chequamegon Bay. We did the tows here, we did water sampling with our CTD rosette, and also this tow route here. We were there before and after these two significant summer storms in the area. 8 to 10 inches of rain in a 24-hour period, July 11th and 12th. We had our glider in this area right around July 21st. In fact, we were planning to pick it up from Saxon Harbor right about, I think, on July 21st. In fact, we had the boat hooked up to the trailer. We were ready to go that morning, and then overnight this happened. And significant damage in the area. Saxon Harbor was virtually destroyed with one fatality, unfortunately. So it gave us a chance to look at how much has that changed in that area and start to add our nutrient data to this larger body of data that's been collected by folks at Northland College and USGS and elsewhere. Randy Lair and folks at Northland College put together a ROMS model for this area, and you see this gyre here. And it's really interesting when you run this through time. I didn't bring the animation, but you see this cold water from the lake start to push in on this area, and oftentimes it seems to keep it away. Occasionally, Chequamegon Bay squirts out as this lake water moves in, and normally it moves to the north of Madeline Island. Every once in a while it moves to the south. That's partly what we were interested in. Real quickly, this is some data that Hudson at Northland College has compiled, both EPA data and Northland College data about total phosphorus values for Chequamegon Bay, showing that through time from 2008 to 2018. So we're developing a long-term record of those phosphorus levels in the area, which I think will be interesting going forward. And then I had to add this one slide about watersheds. As we think about tributary loads, it's really interesting to think about the size of the tributaries and what they might be contributing to these areas. In this case, the Bad River contributing a significant amount to Chequamegon Bay area. And these are watersheds in green are 1,000 kilometers and larger. And I think if we looked at the frequency distribution, cumulative size distribution of these watersheds, we'd see that very few watersheds, very large watersheds, cover the majority of the total basin area. And maybe where we focus our efforts first in terms of thinking about nutrient loads to those areas. So in conclusion, we have elevated phosphorus levels likely to continue. Combined with warming, we're likely to see more blooms. It's surprising, but now, unfortunately, it's not so much a surprise. We're going to see those periodic flushing of Chequamegon Bay. I think with some enhanced or increased hydrodynamic models, we can understand that over time. Hopefully we can run those models maybe over decades rather than just 1 year at a time. And then bring a better understanding of those tributary loads, which we'll hear more about today. And then with continued monitoring, hopefully we'll understand.